All right, here's another problem, but you'll notice now, not only do we have x's and numbers on one side, but also on the other side. And we're just going to focus on one side at a time, there's like terms that we can combine. So, and yeah, we'll make the answer a fraction if we need to. But what this means right now is I'm pretty much ignoring that right side of the equal sign. I'm completely ignoring it, okay? And this goes back to the idea of just kind of focusing on one part at a time of problems, you know, simplifying them or breaking them down into smaller, more manageable parts. So right now I'm just looking at one side of the equal sign. Well, I'll get rid of this later, but I don't want to even look at this stuff. And I got negative 4x's minus 7x's right there. Those are like terms. So I can combine these, right? So this is how many x's? Negative 4x's minus 7x's, that'd give us negative 11x's. But then I have these other like terms to combine, the negative 1 and negative 3. Negative 1 minus 3, that's going to be negative 4. Okay, so that's as much as I can simplify. I got an x term and a constant term, number term, nothing else I can combine here. So I would be looking then to go now to the right side of the equation. So I'll move this, in fact, kind of covers up that. So at this point, I'm looking at the right side and I want to combine any like terms. I have negative 9x's, and again, that's a positive 1x's. That would give us negative 8x's. And then the negative 6, it just stays negative 6 there, okay? So I've completely simplified this equation right here. So this is what I'm left with, right? Negative 11x minus 4 equals negative 8x minus 6. And we're looking at a problem that's very similar to the one that we just barely did. I want to put all my x's on one side and all my numbers on the right side. Now on the other side, I should say. On the last problem, though, I put all the x's on the left and the numbers on the right. This time I'm going to show you that it doesn't matter which side you put the x's on, okay? It does not matter which side you put the x's on, which means I'm shooting to have all my x's on the right and then all my numbers on the left. Now, the way that I have this set up, and again, you can keep it always the x's on the left, numbers on the right. Most students prefer to do that, but I'm showing you that it doesn't matter, right? This negative 11x is on the number side of the equal sign. So that means that I'm going to have to zero it out. Okay, so a negative 11x, I'll have to add 11x's to make that 0. Just if I do it to one side, I must do it to the other side as well. So working through this, negative 11x's plus 11x's, that becomes 0, just like we thought it would. Then I'll drop my negative 4 here. This is now equal to negative 8x's plus 11x's. That's going to give me 3x's right there. And then the negative 6, once again, it just gets dropped. Nothing, we didn't operate with it, right? Now, scanning this problem, I have a number on the left side, that's good. I got 3x's here on the right side, and now I got negative 6. This is in relation to the equal sign. Negative 6, though, it does not have an x term. So I got to zero it out as well by adding 6 to both sides. Okay? And once again, we look at this term as negative 6, right? Because it takes the operation to its left as its sign. That's negative 6. Negative 6 plus 6 there, that's going to give us 0 just like we want. But now on the left, which is just where the numbers are, negative 4 plus 6, yeah, that's going to be 2. And that's going to equal that 3x, which I just need to drop it. Okay, so 2 equals 3x. I'm down to my final principle of equality. I've used the addition principle of equality twice. Now I will have to divide both sides by the coefficient 3. And this gives me pretty much my final answer there because the coefficient now is a phantom 1. But I get 2/3 out of that.
Jordan Sharp, please come to the front office. Jordan Sharp to the front office, please.
So if you go back and replace all the x's with 2/3 in the original statement and then just plug that into a calculator, you'll find that 2/3 is the answer. So I boxed it in. That would give you a true statement there from the beginning. Now I'm going to point this out with this problem. Okay, so I'm kind of backtracking here. Is you notice at the beginning when I added 11x's to zero this out, I put this plus 11x's below the other x's. I did not put it below the constant term or the non-x term. That's on purpose, by the way. Okay, because if I add 11x's to negative 6, they're not even like terms to combine. So I have to combine it with the other x term, which in this case is the negative 8. So you want to keep that in mind. Even like down here with the negative 6 when I added 6, I put it below the negative 4. Well, there's no x terms. Yeah, but I line them up so that I know that I'm operating with like terms.